from homework, question 6 and question 8, and then we will move on. So for question 6, it gives us two complex numbers, Z1 and Z2. And it also gives us that Z1 divided by Z2 is 1 minus I, where P is a real constant. And for part A, we need to find Z2. But we know Z1 and we know the relationship between Z1 and Z2, so we can write that down. It says that for part A, we have Z1 over Z2 equals to 1 over I. But we know what we know Z1. So we can plug in Z1. So we get 3 plus 2 pi over Z2 equals to 1 minus I. And then we can get Z2 out. What does Z2 equals to? What is the value of Z2? If you rearrange this equation,
3 plus 2 pi divided by 1 minus I.
Great, that's it. Now you'll realize we cannot make Z2 into the form A plus BI if we don't do something to this fraction. Do you know what we need to times by this fraction so that we can get rid of the 1 minus I
The complex
in the denominator?
quantity.
Yes. And what is it?
1 plus I.
Yeah. Then, if you multiply by 1 minus I times 1 plus I, you get 1 minus I squared. And in the numerator, you just need to expand the bracket. Pretty easy. Plus 2 pi minus 2p. And the denominator will simplify to 2. And the numerator, we will group the i's together and the real part together. Imaginary part with imaginary part, real part with real part. What is the real part here?
Just the 3. Wait, is the p part of the real part?
Yes. Anything without the I. That's it.
Okay.
3 minus 2p. And then plus 3 plus 2pi is our imaginary part. Okay, but this is still not in the form A plus BI as the question required. So we just need one last step. We will group them 3 minus 2p over 2. This is our real part. Remember how to separate fractions? So then we plus 3 plus 2p brackets I over 2. That's it. This is in the form A plus BI, and that will be our final answer for part A. Any questions here?
No.
All right, let's move on to part B. Find the value of P. But now it gives us another clue. Argument of Z2 equals to arctan 5. So what is the argument of Z2? Well, we know the modulus argument form of Z2, so we can use that to derive argument of Z2. So it is basically inverse of 10. 3 plus 2p over 2 divided by 3 minus 2p over 2. And now, this fraction may look a little scary, but both of them has a denominator of 2, so we can cancel that out. And we only get inverse of 10, 3 plus 2p over 3 minus 2p. And what does that equal to? Inverse of 10, 5. So we can make an equation here so we can solve our p. So do you know what the equation will be? Here.
Won't we leave it like that?
No, we want to find our p.
So 3 plus 2p over 3 minus 2p is equal to 5.
That's it. And then we times both sides by 3 minus 2p, and we can simplify. So 3 plus 2p is equal to 15 minus 10p. Subtract both sides by 3, add both sides by 10p, so you will get 12p equals to 12. And finally, p equals to
1.
That's it. That's it for part B. Any questions after now?
No.
All right, let's move on to part C. Find the value of modulus set 2. Any ideas what we need to do here?
So we'll substitute the 1 into
Yeah, that's it.
minus 2p.
So p is equal, because p is equal to 1, therefore 3 minus 2p over 2 plus 3 plus 2p over 2, what we found earlier. I is equal to, just substitute, so by half plus 5 over 2i. So we know we can already write Z2 in this form, so we can easily find out the the modulus of Z2. Can you tell me how I can find the modulus here?
Root a half squared plus 5 over 5. Isn't that just 1, though?
Which one? 5 over... oops, that's not 5 over 5. 5 over 2.
Okay. 5 over 2 squared.
That's it. And when we simplify, we'll get root 26 over 2. And that's it. You will leave your answer like this. If you convert it into a decimal, it wouldn't be as accurate as as if you would leave this in third form. So it would be a better idea to leave it like this. Okay, let's move on to part B. Show Z1, Z2, and Z1 over Z2 on a single Argand diagram. This will be pretty simple because we know all of them in A plus BI form. So Z1 is equal to 3 plus 2i, Z2 is equal to half plus 5 over 2i, and Z3, there's no Z3, Z1 over Z2 is equal to 1 minus I. Question has given us this. So do you remember in the Argand diagram what is on the x-axis and what is on the y-axis?
On the y-axis are imaginary numbers, and on the x-axis are real numbers.
Excellent. So our Z1 will be somewhere like something like this. That is our Z1. Just drawing a really rough sketch. And Z2, do you think Z2 will be above Z1 or below Z1? So would it be here or here?
Below Z1? No, wait. Above Z1?
Yes, that's it. Should be above and slightly somewhere here. And then Z1 over Z2 should be somewhere here in the fourth quadrant. Z1 over Z2. All right, that's it with question 6. We will move on to question 8 now. Okay. Now in question 8, it's given Z1, Z2, and Z3. Actually, Z3 is given in the form A plus BI. We don't know A nor B. So part A asks us to find the exact value of modulus Z1 plus Z2. Okay. In order to do that, first we need to find what is Z1 plus Z2. And then we can find what is the modulus of it. So Z1 plus Z2, if you were just to add these two complex numbers, it would be 6 plus 6i. You just add real parts together and the imaginary parts together. Now we just need to find its modulus. Z1 plus Z2. The same way like we did before, 6 squared plus 6 squared. And that will give you 6 root 2. And that's it. Part A. Easy?
Yeah.
Okay, let's go on to part B. Given that W equals to Z1 times Z3 over Z2, find W in terms of A and B, and give your answer in the form X plus IY. Okay. So we need to find what is Z1 times Z3 over Z2. Let's represent this here. Z1, Z3 over Z2 is equal to 4 plus 2i times A plus BI. 2 plus 4i is the denominator. Okay, and then we will multiply both numerator and denominator by which fraction?
2 minus 4i.
Well done. Minus 4i over 2 minus 4i. And this will give us, I'll just do the simplification for you. It would be 16 minus 12i. This would be pretty simple. 4 plus 16 in denominator. A plus BI remains. We need to continue to simplify. So we will get 16 minus 12i times A plus BI over 20. Can this be simplified further?
I don't think so.
Look at the numerator and the denominator. Do you see a common factor between 16, 12, and 20?
4.
Yes, so you can take out the 4. So you will get 20 divided by 4 is 5, and 16 by 4 is 4 minus 3i times A plus BI. And then now we need to expand the brackets. Just multiply the terms. Can you tell me what I will get in the numerator if I expand the brackets, please?
Does the BI stay together?
Actually, you need to multiply like all the terms here, 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 and here. Can you simplify it for me, please?
4a plus 4bi.
Yeah, together.
Minus 3ia.
Yeah, 3ai. What else?
Minus 3bi squared.
That's it. Okay, and then let's simplify further. So the minus 3bi squared can be seen as plus 3b, so we can group the real parts with the real parts for a plus 3b. And the imaginary parts together plus 4b minus 3ai. And the denominator stays. And then we can separate these two fractions into two fractions, so 4a plus 3b over 5 plus 4b minus 3a over 5i. That's it. We have presented our answer in form of x plus iy. Let's move on to part C. Part C. Given also that w equals to 21 over 5 minus 22 over 5i, find the value of a and b. Tell me what I need to do here to find a and b. So we will need to create. Yeah, tell me.
Do you mean that we need to like create an equation and then equate it to 21 over 5?
That's it.
22. Okay.
So 4a plus 3b over 5 is equal to what number?
21 over 5.
Since they both have a denominator, so it can be cancelled out, we get 4a plus 3b is equal to 21. Let's also equate the other imaginary part. So you get 4b minus 3a over 5 is equal to negative 22 over 5. So 4b minus 3a to negative 22. Do you know what these two equations are called?
Simultaneous equation.
Hold up, that's it. And then we're just gonna simplify. We can simplify this to 12b minus 9a is equal to negative 66 by multiplying both sides by 3. And on this side, we will simplify by multiplying both sides by 4. So we get 12b plus 16a equals to 84. Please check if I made any mistakes. I am not sure. Yeah? Okay. And then we're going to group these two equations, the last two together, and we can get rid of the term b. So 16a minus negative 9a is equal to 84 minus negative 66. So lastly, 25a is equal to 150. Suppose a is 6. And if we plug in a to be 6, let's say if we plug it into any of these four equations will be okay. Preferably the first two. The first two here. Can you tell me the value of b, please?
Wait, 1 sec. So 24 3b is equal to 21. Like 3. No, negative 1.
Yeah, negative 1 it is. Okay, that's it. We found our A and our B. Let's move on to question D. I will do question D here on the top. I don't have any space there. Okay. Argument W. Giving your answer in radians to decimal place. That's easy. Tell me, how can we find argument of W? We want to first construct a Argand diagram. Can you please tell me where the angle will lie?
In the third quadrant?
Here?
No.
No? No, but this is W.
Yeah, okay.
Yeah, that's it. Which one were you looking at?
I don't know, like, what
Yeah, it's okay. Here will be our angle W, argument of W. And if it's here and this is argument of W, do we need to do anything to it? Or can we just take the angle?
we need
If
to
it's
do
in the fourth.
something to it.
What do we need to do?
We
Is
have
it
to minus something. I think minus pi. Wait, is it minus?
If you want to minus pi, it should be in the second quadrant. So in the first quadrant, we don't do anything. Tell me what we need to do if it's in the second quadrant here. If it's in this part.
Oh, okay. Then it's pi minus.
Yeah, and then take the negative. So let's revise a little. So here is theta, and this angle will be pi minus theta brackets. You take a negative sign, and if it's here, what will it be? Actually,
Isn't it the other way around? Yeah.
Yep, sorry. This is pi minus theta. Yep. And here will be negative 5 theta. Well done. And in the fourth quadrant, what will it be?
Just negative theta.
That's it. So you need to do -1 times argument of W. And first of all, what is argument of W? What trigonometric function do we need to use?
Tangent.
So arctan or inverse of tan, 22/5 divided by 21/5. It's really tall. And we can simplify the denominators. So we get inverse of tan, 22/21. Tell me what I will get. Oh, all of them has to be multiplied by -1.
Negative 0.80.
Negative. If it's to 2 decimal places, should be 0.8, not 0.
Oh, 1.
0. Yeah, that's it. That's our question 8. Okay, any questions up to now?
No.
All right, we should move on to something new today. So let's begin. We will look at modulus argument form of complex numbers. We might have encountered this a little bit from our last lesson, but we'll go in more details today. So for a complex number, let's call it Z. The modulus of Z, we will name it R. And the argument of Z, we'll name it theta. So the modulus argument form of Z is Z equal to R brackets cos theta plus I sine theta. So these two thetas that you can see over here and over here are the same. They are the argument of Z. And the R in front is the modulus of Z. That always applies. Okay, so if you want to represent this on an Argand diagram, it simply look like this. Imaginary on here and real here. There it is. That's our Z, which is x plus iy. So here is y, and here is x, and this angle is our theta. What is this? This is the length r. It's 90 degrees. That's it. So let's look at some examples regarding the modulus argument form, because that's all it is with its theory. Let's move on to example 6. Express z is equal to -√3 plus I in the modulus argument form. Okay. Let's do that. First of all, we will construct an Argand diagram. Can you tell me which quadrant will this z lie?
And the second one?
Well done. That's it. This will be 1. This will be √3. This will be our A, and this is our argument of Z. And this is z. Let's find our r first. So this will be root of -3 bracket squared plus 1 squared. So the same way like we would have found the modulus. This is equal to root 4, so equal to 2. And what is our theta? There's an equation for theta.
1/√3. The inverse of it.
Yes, so pi minus arctan 1/√3. So this is equal to, now I want arctan in forms of radians. What will it be after we simplify?
I have to switch calculators.
How many do you have?
2.
I have 2 as well.
Five pi over 6.
Yes, that's it. Oh, you gave me the final answer. That's right. Pi over 6. Excellent. Now, what is z? After we found r and theta.
It's still the same thing, no?
Yeah, it's still the same thing, but in this form, what will it be?
It'll be 2 cos 5 pi over 6 plus I sine 5 pi over 6.
Great. And we should move on to example 7. It's pretty similar, but in another quadrant we're working with. Let's have a go. Actually, I should change to another color. More festive color. Express z is equal to -1 minus I in a form r times cos theta plus I sin theta. Hey, in which quadrant?
The third one.
Getting better and faster. So here will be 1. Here's also 1. And this is our A, this is our argument of Z. Okay. What is R?
1 plus 1, like 1 squared plus 1 squared.
Yeah. Writing it. Oh, yes, which is root 2. And what is theta?
Arctan 1/1.
And then do we need to do anything to it?
Yes.
What do we need to do?
Subtract it from pi and then times it by -1.
Yes. And if we simplify that, we should get -pi plus pi over 4, I think. Yep. Is equal to -3 pi over 4. You get the same answer?
Yes.
Okay. And finally, that is equal to root 2 times cos negative 3 pi over 4 plus I sine negative 3 pi over 4. And it would be a good idea to put a bracket around this negative number. That's it with this example. Any questions?
What is the, like, where negative pi, the range? Why is it there?
That has to do with the Argand diagram. So this formula we're using works for a complex number in any quadrant of the Argand diagram, whether it's in the first, second, third, or fourth. But the argument theta is usually given the range negative pi to pi. But although the formula works for any value of theta measured anticlockwise from this axis here. But do you know what is negative pi and pi in degrees?
No, negative 90?
So how do you change? So pi is in radian form. How do you change radians into degrees? What do we need to multiply?
180 over pi.
So if you do 180 over pi times pi, you simplify out because pi is just pi over 1.
It's 180.
Yeah, it's 180. So it's from the positive 180 end, which should be here. Because you always start from the positive real axis. Okay? So this is 180. And negative 180 is this value. So negative 180, we go from the bottom here, go here. This is our negative 180. So it just includes all the angles in the Argand diagrams. Yeah, do you get it?
Yeah.
That's it. Let's move on to the next part. We'll introduce something new now. Multiplication and division of complex numbers. I know that we've done something like, for example, 3 plus 2i times 2 minus i. But now we're not working with this. We're working with its modulus. So the theory is for any two complex numbers, z1 and z2, z1, z2 modulus is equal. You can separate them into z1 times modulus of z1 times modulus of z2. And the same way applies for argument of z. So argument of bracket z1, z2 is equal to argument of z1, but not times now. It's argument of z1 plus argument of z2. And to combine these two together, you get z1, z2. When you multiply these complex numbers together, you will get r1 times r2 times bracket cos theta 1 plus theta 2 plus I sine theta 1 plus theta 2. And there's actually a proof for this, which I can show you if you're interested. And just before that, I will show you something else, and you can tell me if you want to learn more about this. So if we divide z1 by z2, what do you think this will simplify to? Yeah? What do you think?
I don't know, actually.
Not? So if you want to simplify this into still a fraction, the numerator and the denominator will just get this form. Modulus of Z1 over modulus of Z2. Same way for argument of Z1 over Z2. Same like for here and here. Before we are adding these two, but since it's division now, we are subtracting. Argument of Z1 minus argument of Z2. We can prove the results with the modulus argument form, but proving is quite long here. One last thing. R1 over R2. This would just equal to, Z1 over Z2. This is equal to R1 over R2 times cos theta 1 minus theta 2 plus I sine theta 1 minus theta 2. Okay, hopefully you did not fall asleep and we can go on to some examples. That's it with the theory. Actually, I can send you the proving because it take a lot of time if we do it right now. Okay, let's go on to some examples. Go on to example 8. For part A, we need to find what is modulus of Z1, Z2. Okay, first we will simplify Z1, Z2. What is Z1, Z2? Well, according to the theory, Z1, Z2 can be simplified to Z1, modulus of Z1 times modulus of Z2. So we do that. Times Z2. What is modulus of Z1? What is it? Yeah. And modulus of Z2? 4. Well done. So that is that is our answer for part A. Part A, the second part. We need to find argument of Z1, Z2. How do we simplify that? Argument of Z1, Z2.
Subtract them?
No, if it's division, it's subtraction. If it's multiplication,
It's addition.
Argument Z1 is equal to what?
5 pi over 12.
An argument of Z2?
Pi over 12.
So combining them together,
6 pi over 12.
yes. Which can be simplified to which fraction?
A half.
Half what?
Pi.
Half is correct. Yes, half pi. That's it. Let's move on to part B. Hence, write Z1, Z2 in first modulus argument form and secondly the complex number form. SBI. Okay. Well, this is easy because we know our R and our theta. Yes.
So it's 12 cos pi over 2 plus I sine pi over 2.
Excellent. How about the second part?
Do we just like times them?
Yes, so we need to simplify cos of pi over 2 and sine of pi over 2. You can use your calculator here.
Does that also need to be in radians?
Yes. Anything with complex numbers, Argand diagrams, it is with radians.
Cos of pi over 2 is 0.
That's it.
And then sine pi over 2 is 1.
We plug it back in. 0 plus I times 1. That is just 12 times 0 is 0. So what we get left is 12i. The second part. That's it for question 8. Let's move on to question 9. Got a couple more to go. Question 10, and then we'll look at loci in Argand diagram, and that's it. Given Z1 and Z2, we need to express Z1, Z2 in form x plus iy. Okay, what we need to do here is rewrite Z2 in the form r times cos theta plus I sine theta, because currently between cos theta and I sine theta, we see a negative sign, and we don't want that because it's not a form. So we are going to rewrite Z2 as our first step. Okay. This would be cos 2 pi over 5, we insert negative, equal to cos 2 pi over 5, and sine of negative 2 pi over 5 is equal to negative sine of 2 pi over 5. This may seem a bit confusing if you've forgotten what we did, I think, last year in IGCSE. You remember the graph for sine and cosine and how in which direction they go. So there is this formula, cos, supposed to remember. So cos negative theta is equal to cos of theta, and sine of negative theta is equal to negative sine theta. Okay. You would like a quick proof of this? I can draw a diagram here. I want you to identify which one is for sine and which one is for cosine. Okay. And let me draw the other one in this color. The other one will be like this. Okay. Is the green one cosine or the black one is cosine?
The black one?
Excellent. And of course, the green one is the sine. So if the black one is the cosine, which line is the line of reflection? So which line is the line of symmetry on the black curve? Is it the y-axis or the x-axis? Here's the x, here's the y.
The y-axis?
It is. So if you were to reflect from the right-hand side of the y-axis onto the left-hand side, you will get the same distinct shape on both sides. So you can get the x inside the function because that f of negative x is equal to f of x for the black curve. But when you look at the green one, it does not reflect on the y-axis anymore. If, let's say, you take this part here on the green curve and you reflect it on the y-axis to this side, right? And then if you reflect it again back on the x-axis, you get it there. So you will get sine of bracket negative theta, that is to reflect this part on the other side. And then you take negative of some theta. So taking a negative in front of that function f of x, you're reflecting it on the x-axis. Okay, and that is our green graph. So that is just derived from what we learned before. And yeah, let's continue with the question. So Z2 can be written as 3 times cos negative 2 pi over 5 plus I sine negative 2 pi over 5. Just plugging it in. Now Z2 is in the modulus argument form. We can find Z1, Z2 now. What is Z1, Z2?
Do we actually have to like? Yeah. Okay.
Now you can see better.
Can I just put the whole thing in my calculator?
Not advised to do so. Tell me, what would you do?
Just
You don't have that calculator.
When I don't have a calculator? I mean, how would I not have it if I'm going to like simplify I over 15?
Okay, yeah. That's a good argument. Yeah, use it then. So 2 times 3, write it out in full. Cosine of pi over 15 minus 2 pi over 5 plus I sine over 15 minus 2 pi over 5 will be equal to 90 plus I sine pi over 3. Alright, did you get it?
No.
Actually, for this cosine negative pi over 3, you can actually work it out without a calculator. Same for sine negative pi over 3. As long as you convert it into that degree, then you can work it out. So negative pi over 3 should be negative 16 degrees. So you just work out negative cosine of 16. Do you remember what is cosine of 16?
I should.
With this, you can recognize what I'm drawing.
Oh yes, I do. It's a half.
Yes, that's it. So you can just write 6 to half plus so sine of negative pi over 3 is just sine of negative 60. What is sine of negative 60?
Would that not be a negative half?
No, but you told me cosine of negative 60 is a half, but sine, counting from the other side, this is the sine direction, this is the cosine. 0, 30, 40, 45, 60, 90. So bend down the fourth finger. It's √3/2.
Oh, okay.
It's okay. I don't think you will need to do this without a calculator. Hopefully they wouldn't ask you to do this. What is your final simplification after all these?
Three plus I. One sec. Next time. -3 √3.
Mm-hmm.
But do I still plus the I?
I know. The I goes with the negative √3/2. So when you multiply it in positive and negative, you get a negative. So just minus 3/3i. No, but do you see why it's minus 3/3i, but not plus?
Because of the negative √3.
Yes, that's it. So that's our final answer for example 9. Any questions for example 9?
No.
Okay, let's move on to example 10. This is our last example before we move on to the Kine-Argand diagram. We get to finish that. Okay. Express this in the form x plus iy. This shouldn't be difficult. You just minus the angle and divide the modulus. Let's go. √2/2 because of pi/12 minus 5/6. Same for sine, so plus I sine pi/12 minus 5/6. Difficult part here is not to list this, but to simplify this. Okay, what is pi/12 minus 5/6?
-3/4 pi.
That's it. And pi/12 minus 5/6?
The same thing.
That's it. Then we need to simplify again. We use a calculator here. √2/2 should be 2. He will tell me the final answer. Plus I -1/√2. Entering everything onto the calculator as you said. Or what you can do is convert it into degrees and find without a calculator. So this one will be -1/√2. This one would be -1/√2 as well. And √2 simplifies. So yeah, did you get a final answer?
No, I stopped. I stopped to listen.
Okay. Okay, let's simplify together then. √2. There's another √2. So that's it. Just write what's left.
Just the 2, the -1.
Yeah.
I.
Make sure to group them like this. Minus how many I?
1? -1?
Yeah, but there's 2 left. Can't leave it alone.
-2? Hi?
But
Wait,
that 1 is alone then if you take the 2. Take both.
-1/2?
Yes, -1/2. But you left I home alone. Add it as well. Yes, that's it. We're done. Example 10. Let's move on to one last thing, one last theory today. Hopefully I can squeeze that in. Yeah. So for Z1 to be x1 plus iy2 of y1, actually, yeah, Z2 is equal to x2 plus iy2. You just x1 and y1 and x2 or y2 are just two different sets of real numbers. And argument, no, modulus of z2 minus z1. What does it represent? It represents the distance between the points. It's the distance between z1, z2. Make sure you know what you're calculating. So if it asks you to find modulus of z2 minus z1, you know that is the distance. Very important to understand the concept. It's the distance between z1 and z2 in an Argand diagram. So let's see visually how it is like. The real part. And this should be our z2. This is our z1. z2. z1. And where is modulus of z2 minus z1? Here. Where it joins. This is a bit like the vector. If you want it to go from actually here to here, you will add z2, subtract z1. Bit like that. Okay. One more thing you need to know is z1 is equal to x1 plus y1. The locus of this point, of the point z on Argand diagram is such that z minus z1 equal to r. And do you remember the equation for a circle in terms of equation? The x and the y?
No.
No. Okay. So it will be x minus a squared plus y minus b squared is equal to r squared, in which a and b, this is the center of the circle, r is the radius. Hopefully that rings a bell. Did we do equations of circles together before?
I'm not sure. I don't think so.
Okay. So that is the equation for a circle. It's pretty simple. Just identify your A and B. That's the center. When you know the center, you know the radius, you can construct your circle. So we're going to use this in loci and Argand diagrams. So modulus. Wait. Yes, modulus of z minus z1 is equal to r. R is the radius, and we know that what z1 is. We have written it out. It's x1 plus y1. So we can write it as z minus x1 plus I y1 is equal to r. And we know that according to the equation of a circle, x1, y1, this is our center. And r is the radius. That's something you have to remember. And actually, I can prove it to you right now. How this we did here relates to equation of circle. So you're not too familiar with the equation of circle either. So it would be z minus z1 equals to r. This is a Cartesian form of the equation. Then we're going to substitute z with x minus we'll substitute z with x plus yi and z1 with x1 plus y1 I. So both in Cartesian forms. X, and you group the real numbers, real parts together and imaginary parts together, we'll get I times y minus y1. And to break this form, we can square both sides. So you get this squared is equal to this squared. And if we square that, we can get rid this and x minus x1 squared plus y minus y1 squared is equal to r squared. And this form is exactly the same as this. Okay, that's it. Let's go on to some questions. Hopefully I didn't confuse you too much. Yeah, let's go on to some questions so you can better understand this. Given that z satisfies z minus 4 is equal to 5, sketch the locus of z on an Argand diagram. So according to this form here, this is a circle, and the center of the circle we know. We also know the radius of the circle. So the center of the circle is 4, 0. Why is it 4, 0? Because according to this form, z minus x1 plus iy1, we can see clearly that there's no I. There's only this negative 4, and this negative 4 is the x1 it represents. So the center is 4, 0. But what is the radius? The radius is simply 5 because it's equal to 5. So this is the center, and the radius is 5. Don't worry if it seems a little confusing at the moment, because we're going to do lots of practice examples together, and we'll give you more for homework until you get it. And presenting it on a diagram. This is the center of the circle, and that's our circle. Okay. And the radius is 5. You can represent it like this. 5. That's it. We're done with part A. Let's go on to part B. Find the values of z that satisfy modulus z minus 4 equals to 5 and imaginary part of z is equal to 0. So when we say imaginary part is equal to 0, it means that we're finding the coordinates which intersects which axis, the real axis or the imaginary axis. Yeah? I'm listening.
Hello?
Yes? Can you hear me?
I couldn't just now.
Okay. I was asking, how can you find the value of z that satisfy these two equations? So if we want to find the coordinates that the circle passes with imaginary part of z is equal to 0, it's the first part stated here. Do we find where it intersects the imaginary axis or the real axis?
The real axis?
And which 2 points does the circle intersects the real axis?
At the center?
No, it does not. The center of the circle, sure, you're right, but the center of the circle is not on the circle. We want to now find which point on the circle intersects the real x-axis. It's these 2 red points, right? But we want to represent these 2 red points in coordinate form. We can work that out. We know that if it intersects the real axis, of course, the y-coordinate has to be 0. It's given, but we just need to work out the x-coordinates. Work that out with the center of the circle and the radius of the circle. Think.
Hello?
Can you not hear me? Can you hear me?
Yeah, I can now.
Okay. But did you hear what I was saying before?
No.
No? Oh no. So for part B, we want to find where the circle intersects the x-axis. Okay, so we can derive that from the center of the circle and the radius of the circle. We know that for the y-axis it's 0, but what are the x-coordinates? So what is this point? Could you confirm that you can hear me?
Yep. Yeah, I can. But
Okay, that's great. You're thinking.
how do I know what the point is?
Well, you know the center of the circle, and you know the radius. So the radius stays the same wherever it goes, right? From the center of the circle. So we know this is 4 and this is 5. What is that point?
I still don't know.
You don't? So this is 4. This length is 5. What is the coordinate? Just 4 plus 5. That's it.
Oh, okay.
Yeah, because from here it's 4. Then here is 5. So this coordinate 4 plus 5, which is 9. Okay, the same way, I want you to work out this point. What is it? Remember that? Yeah. Yep. Sorry, what did you say?
I'm so lost.
Okay, so I will draw the circle here so you can see it better. This has coordinate of 4, 0. That means this is 4. And it has the radius of 5. That means here is 5. Here is also 5. It's the radius. So we found this point to be 4 plus 5, which is 9. So this point has a coordinate of 9, 0. Because we know the length between the 2 points, if we know the length between 2 points and we know one point's coordinate, we can work out the other point's coordinates. So the same way, we know 4, 0 is the coordinate of the center, and we know from this point to go to this point marked here, marked green, the distance is 5. So what do we need to do to its x-axis? We should subtract from it. 4 minus 5, 0, which is just negative 1, 0. Is it a little more clear now, or still not clear?
No, it does make sense.
Okay, excellent. Now we worked out where it cuts the real axis. What we can do is work out z. Z is just the x values that we found. So z is equal to negative 1 and 9. Yeah, and we've worked out the first part. We should work out the second part as well. Let's work out the second part as well. And that will be it for today. It's Christmas time. Okay. Z minus 4 is equal to 5. That's given. We can rewrite this by writing Z as x and y. So we can rewrite it as x minus 4 squared plus I squared equals to 5 squared. Why? Because do you remember the equation for circle we did before, which is over here? This is the equation of a circle. If we know its center, we know its radius, we can work out the equation of the circle. And according to here, we do know the center of the circle. It's 4, 0. And the radius is simply 5. So because 4, 0 is the center, so we just do x minus 4 squared. And then 1 minus 0 squared, because it's minus 0, we ignore. So just y squared is equal to 5 squared, because that's equal to radius squared, according to the equation given. And then we continue to simplify. We'll write 0 minus 4 squared is equal to y squared equal to 5 squared. This would be 16 plus y squared equal to 25, and y squared is equal to, can you rearrange what y squared equals to?
25 minus 16.
Which is?
9. So y squared is 9.
What is y?
3.
Only 3?
Positive and negative 3.
That's it. And let me just ask you if you understood this. Why did we let x to be 0 here? How did this go from this to this? Do you understand it?
Because no, I don't actually.
No, okay, let me explain it. So because the question says real part of z is equal to 0, and the real part is the x. It says that x is equal to 0, so we're just substituting x equal to 0. So we use the information given in the question. Your part is just x. That's it. We worked out that y is equal to plus minus 3. So where does the circle cut the real axis?
At 3? Well, -3, 0, and 3, 0.
No, the other way around. Because now
0,
it's the y.
3.
Yes.
3. Okay.
That's it. Good that we make mistakes here, so next time we get everything perfect. And then the values of z and what are the values of z?
4,
Of z.
0. No,
What?
wait.
What is it?
It's -1, 0, and 9, 0. Right?
Z.
Is -1 and 9.
No, not quite in this form. X plus IY. We know X and we know the Y. We're plugging it in. That is a complex number.
Okay.
Okay.
Well, what do I do if the I is like 3 and -3? Do I just plug in 3?
Yes, you do. So the Z will be 3I and -3I. You're right.
Oh,
That's it.
okay.